Today our group will present about our project, that is Synergism effect of activated carbon and clamshell CaCO3 for methylene blue adsorption. And this is our group member, that is Hemashini, Nurziana, Muhammad Shawal, Muhammad Nurizal, and Rebecca Sinang, and our supervisor is Dr. Muhammad Nazri Abu Shah.
Hi, my name is Hemashini. Today I'm going to introduce about our project. Okay, first is I'm going to introduce what is wastewater. Wastewater contains two types of compound. So first is organic compound. Now this in organic compound wastewater. In our project we are using organic compound wastewater, and we also use methylene blue as a methylene blue solution as the wastewater. So we are treated with methylene blue in our project. Okay, other than that, we have to use a good source of absorbent to produce a good filter. So in our project we are using activated carbon. Activated carbon is a type of good absorbent of colors, and it also can induce the pH value of water. When it's induced the pH value of water, we have to add another potential absorbent which acts as pH neutralizer. So we add CAMSHELL, which is known as calcium carbonate, will give calcium carbonate and in our project, which can neutralize the pH value of wastewater. Okay, so the combination of activated carbon and CAMSHELL will give a good and high ability of water filtration system. That's all for introduction. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nurizal bin Igal, DPE004, will presentation about a problem statement in our project. Problem with untreated water disposal practice and wastewater contaminant by human, chemical and industry. Surface water and underground water are contaminated from such which can lead a risk to nature. That's our problem statement in this project. After that, I will present about objective. Objective in our project is to synthesize clamshell CaCO3, which have potential as adsorbent and pH neutralized in filtering water system. Number 2 is to study absorption effect of activated carbon and clamshell CaCO3 toward methylene blue solution as wastewater. Thank you. This is our scope of research and research or project impact. First, scope of research, absorption of methylene blue by using activated carbon, and neutralize the pH value of methylene blue by using clamshell such as calcium carbonate. After that, research or impact project. Basic understanding on physical properties and chemical properties of activated carbon and clamshell such as calcium carbonate. That's all.
And as for methodology, the aim of our project is to filter the system of wastewater by using the materials that we choose, which are the activated carbon and the clamshells. We started with the cleaning process and then treating the calcium carbonate and concentration of effect on methylene blue, and then last is the absorption test. For this absorption test, we started with the activated carbon. We added 0.5 gram of it and mix it up with 100 ml of one of the samples, which are the 500 ppm, 250 ppm, 125 ppm and 62 ppm, and mix it up by using the magnetic stirrer bar. And for every first 10 minutes we took the sample and then we tested out the pH value. And for this one, we also repeat the same thing for clamshells. We added 0.5 gram of these clamshells and we mix it up with the 100 ml of the samples, and then we mix it up by using the magnetic stir bar for 60 minutes. And then for every first 10 minutes we take the sample and tested out the pH value. And then for the data analysis is that we focus on the absorbent. After treated the activated carbon and the calcium carbonate, which are the.
Assalamualaikum and hello sir. My name is Muhammad Shawal and I will present about a fabrication of filtering water system. So if we see here, this is our component in fabrication filtering system. That is number one is wire gauze break section. You use the wire gauze break section to break the section from the activated carbon and a clamshell. And the second is activated carbon, that is our project material. And the third is clamshell CaCO3 that we use to neutralize the pH of wastewater. And the fourth is wire gauze close section. We use wire gauze close section to close the section of our filter storage. And the fifth is 90-degree elbow pipe. We use this to connect to the filter in our pipeline system. And the number 6 is pipe retainer. We use pipe retainer to make sure our pipeline is not loose and tight to our rector. And the number 7 is 1.5 meter of 4-inch diameter pipeline. So we use 1.5 meter of our pipeline. Want to see the flow of the wastewater. And the number 8 is 4-inch pipeline output section. And this is the explanation for the fabrication of filtering water system. Next, I will explain about the type of filtration storage that we use to compare or to see the different of the solution of our wastewater. And here we use 600 gram of activated carbon in filter storage, and another one we use 600 gram activated carbon and 300 of clamshell CaCO3. In this filtration storage, we use the activated carbon at the top of the filtration storage and the clamshell at the bottom of the filtration storage. And now you see the effect of pH and absorbent for the fabrication the filtering water system. Then for the solution of 600 activated carbon in filter storage, we can see for the solution 500 ppm that the initial of the pH is 7.25 and the final is 6.43. This means when the methylene blue go through the filter 600 gram activated carbon, the pH value is lowest. And we can see also the color changing of the methylene blue here. We can see the final of the methylene blue, the color of the methylene blue is become colorless, and we can conclude that the activated carbon has a good absorption. And for the 600 gram of activated carbon and 300 gram of the clamshell CaCO3 in filter storage, we can see the initial of the pH value for the solution 500 ppm is 7.25 and the final of the pH value is the 6.89. This means when we insert the clamshell, that is CaCO3, it will neutralize the pH value that reduced by the activated carbon. And we can see also the activated carbon still active as a good adsorbent. And this is And this is the result from the reactor or from the filter. Thank you.
Hi, now I'm going to present about activated carbon. Okay, so activated carbon is most powerful absorbent in water filtration, and why we are choosing activated carbon, because activated carbon is easy to install and easy to maintain, and it also can be get at everywhere, and it also can be used at the point of easy. So other than that, activated carbon is content efficient, which can remove chlorine in some organisms, and it also easy and get everywhere. And the raw wastewater is put under contact of activated carbon and check the efficiency of the activated carbon for reducing down the harmful parameter. Okay, other than that, the activated carbon is known as it consists of pure carbon and solid material, and a characteristic of the activated carbon is porous structure and resulting humus surface area, which may have large surface size. Activated carbon is widely used as a purification, discolor and remove water at low cost. Here we got four type of experiment water sample, and we are using four type of different concentration of methylene blue to test with activated carbon. First, we are using 500 ppm. So 500 ppm, that is in 60 minutes we take out water sample in every 10 minutes, and there is color changes around like 40 minutes, and the pure color changes will be happen at the end of the 60 minutes. Okay, this is why activated carbon is good in color absorption. So now I'm going to present about 250 of ppm. In 250 of ppm, we also take every 10 minutes of the sample of water to when test with activated carbon, and we can see the difference in color changing by 40 minutes and 50 minutes of the water testing. In 125 ppm, the concentration of color is not so much difference, but it can show the difference at the point of 30 minutes and 60 minutes. But at the 32.5 of ppm of methylene blue, the color changes cannot be seen by clearly, but most of the color of the methylene blue can be removed and see the clear water at the end of the 60 minutes of 62.5 ppm of concentration of water. The high concentration of methylene blue solution, the low color changes happen at the water samples. So when the concentration of the methylene blue decreases, the color changes can be seen easily in this experiment in this water filter. So in this testing and this diagram show that activated carbon is best solution that used in water filtration system. That's all for.
And as for the adsorption of calcium carbonate, we tested 4 of the samples, which are the 500 ppm, 250 ppm, 125 ppm, and 62.5 ppm, and added it with 0.5 gram of calcium carbonate and mix it up with using the magnetic stir bar, and for every 10 minutes with the total of 60 minutes we take the samples and checking the differences of the color and testing the pH value. And for this one, as you can see, for starting with the 250 ppm and to 62 ppm, the color changes and it gets clearer. This happens because the higher the concentration of methylene blue, the slower the color removal efficiency of the water samples.
Okay, now I'm going to present about the effect of pH value. So as how I said before, there are two different type of concentration in methylene blue solution. First is 500 ppm, second is 250 ppm, and 125 ppm, and 62.5 ppm. So as I said before, activated carbon is good in induce low value of pH value. Other than that, activated carbon also good absorbent of colorless, and it also absorb the odor of some smells. Okay, in this case 500 ppm, the first of the experiment we are using 500 ppm of methylene blue solution. In initial of the pH value is 5.75 and the end is 5.75 value. At the 250 ppm, the initial pH value is 5.87, but the end of the experiment the pH value is shown as 5.75. The pH value can decrease after when using low concentration of methylene blue in feed process with activated carbon. In 125 ppm, the initial pH value is 5.76. After being treated with activated carbon, the final pH value is shown as 5.50. So at the end of the concentration 62.5 ppm, the initial is 6.68. The low concentration of methylene blue, the high the pH value. So after treated with activated carbon, the final pH value is shown as 5.50. So it's proof that activated carbon is good in absorption, and it also can induce the pH value of wastewater. Thank you.
Okay, and as for the effect of pH on calcium carbonate, the solution of 500 ppm, the initial concentration of the 500 ppm is 7.22, for 250 is 6.88, for 125 is 6.95, and for 62.5 is 7.25. And as for the final result, the 500 ppm is 7.06, for 250 is 6.80, for 125 ppm is 7.02, and for 62.5 ppm is 7.23.
My name is Nazila Binti Jadi. I'm going to present about material analysis of activated carbon and calcium carbonate. In figure 4, methylene blue spectrum for the solution is illustrated. From this spectrum, we not found any abnormal peak for functional group methylene blue. FDIR methylene blue solution more present the functional group of hydroxyl, which is we present for distillated water. Besides, in activated carbon and calcium carbonate, we not found any significant result from this analysis. This may activated carbon and calcium carbonate is not suitable for the FDIR analysis. Another reason, the activated carbon and calcium carbonate CAMSHELL is more from as amorphous phase or unstable phase. Other than that, methylene blue also not found in the activated carbon and calcium carbonate. For further analysis, we recommend for the behavior other instrument to indicate the structure of activated carbon, calcium carbonate, and methylene blue. Next, I'm going to present about the conclusion of our project. is Nuziana binti Junaidi. I'm going to present about material analysis of activated carbon and calcium carbonate. In figure 4, methylene